You use your keyboard for hours every day, but you've probably never asked why the letters are in that order. It's not alphabetical. It's not based on which letters you use most. In fact, a study found that QWERTY is one of the worst possible arrangements for typing speed. The layout exists because of a mechanical problem from the 1870s that no longer applies to any device you own. And the reason we never switched to something better might be even more interesting than the keyboard itself. In 1868, every typewriter keyboard was arranged in alphabetical order. Within 5 years, that design was gone. One man's machine killed it. Christopher Latham Sholes was a newspaper editor and part-time inventor working out of Milwaukee, Wisconsin. He built one of the first practical typewriters, and he laid the keys out the same way everyone else did. A, B, C, straight through to Z. It made sense. It was obvious, and it had a fatal flaw. Inside the machine, each letter was attached to a thin metal arm called a type bar. When you pressed a key, that arm swung up and struck the paper. All the type bars hung in the same narrow space beneath the page. Type the letters T and H in fast succession, and both arms swung toward the same point at the same time. They collided. The machine jammed, and the faster you typed, the more it happened. Speed made the machine worse. Sholes had a problem he couldn't solve mechanically. The type bars were fixed. He couldn't change the way the metal arms moved. So he changed something else. He changed the person using it. Sholes studied which letter pairs appeared most often in English words. Then he rearranged the keys so those pairs sat far apart on the keyboard. To type a common word, your fingers now had to travel across the keyboard instead of staying in one place. That extra travel meant the type bars had time to fall back before the next one swung up. No collision, no jam. The alphabetical keyboard was gone and QWERTY took its place. The keyboard you use today was not built for your hands. It was built to protect a machine from itself. But here's the part nobody talks about. The fix might not have actually worked. Look at the top row of your keyboard. E and R sit right next to each other. That pair, E and R, is the fourth most common letter combination in the English language. Sholes was supposed to have separated common pairs. E and R are neighbors. T and H are near each other too. The most common pair in English, and the exact combination that jammed the original machine. In 1949, a researcher ran a statistical analysis on the QWERTY layout. The finding was stark. QWERTY has more adjacent common letter pairs than a keyboard with letters placed completely at random. A random keyboard would have done better. So if Sholes built QWERTY to stop type bars from colliding, the design fails its own test, which raises a question that nobody seemed to ask for over a century. If QWERTY doesn't actually separate common pairs, why does it look the way it does? Two researchers at Kyoto University decided to find out. Koichi Yasuoka and Motoko Yasuoka published their findings in 2011 after going back through original letters, patents, and business records from the 1870s. What they found wasn't what anyone expected. The first people to use the typewriter professionally weren't writers or secretaries. They were telegraph operators. Their job was to sit at a wire, listen to incoming Morse code, and transcribe it into English, fast and without mistakes. Morse code has a problem. Some letters sound almost identical. S, E, and Z are easy to confuse when the signal is faint or the operator is tired. According to Yasuoka and Yasuoka, operators needed those letters close together on the keyboard so they could move between them quickly when decoding ambiguous signals. The keyboard wasn't arranged to slow typists down. It may have been arranged to help telegraph operators decode dots and dashes without losing their place. The story from Chapter 1, that Sholes redesigned the keyboard to separate common letter pairs and stop jams, is the version that appears in textbooks, Wikipedia, and almost every explainer ever written about QWERTY. It might be wrong, The layout on your keyboard may have been built for a job that disappeared before your grandparents were born, translating electrical pulses into language in real time over a wire. But that still doesn't answer the bigger question. Whether Sholes designed QWERTY for type bars or for telegraph operators, neither explanation tells you how this particular arrangement ended up on every keyboard on Earth. That answer involves a gun company, a business deal, and a strategy that locked in QWERTY before anyone thought to question it. In 1873, Christopher Sholes signed a deal with a company that had nothing to do with writing. Remington and Sons made rifles. They had spent the Civil War supplying the Union Army with weapons, and when the war ended, the orders dried up. A factory built to manufacture firearms at scale now needed something else to manufacture. Sholes had a machine and no way to produce it at volume. Remington had a factory and nothing to put in it. They reached a deal, and Remington began building the Sholes typewriter at its plant in Ilion, New York. The machine sold for $125. In today's money, that's over $3,000. This was not a device for ordinary people. Businesses bought it, offices bought it, and the people who used it were hired specifically because they could operate it. And Remington understood exactly what that meant. Beyond manufacturing the machines, Remington offered typing courses. For a fee, you could learn to type on a Remington machine using the QWERTY layout. Once you completed the course, your fingers knew one system. Not typing in general, QWERTY specifically. A competitor could build a faster layout, an easier layout, a layout that made more sense. And it wouldn't matter. Trained typists wouldn't switch, because switching meant starting over. And businesses didn't just need machines, they needed people who could run them. If the available typing workforce was trained on QWERTY, every office in America had to run QWERTY machines. Remington hadn't just sold a product, they had sold the only way to enter the market. By 1891, over 100,000 QWERTY typewriters were in use across the United States. 2 years later, the 5 largest typewriter manufacturers in the country merged into a single company, the Union Typewriter Company. They agreed on a single standard, QWERTY. QWERTY didn't win because it was the best layout. It won because Remington turned typing into a training system that fed directly back to their own machines. Learn the system, buy the machine, hire people who already know the layout. Every step reinforced the next. The keyboard became a trap, and the training made sure you walked in willingly. That strategy didn't die with the typewriter. Buy an iPhone, and your photos live in iCloud. Your messages run through iMessage. Your purchases sit in the App Store. Switching to Android doesn't just mean a new phone. It means leaving behind everything you've built inside Apple's system. That's not a coincidence. It's the same calculation Remington made in 1873. A gun company selling typewriters invented the product ecosystem, and it worked so well that no one has stopped using it since. But here's what Remington didn't plan for. By the 1930s, typewriters no longer jammed. The mechanical problem QWERTY was built around was gone, and a man with a stopwatch, a research team, and 250 keyboard designs decided to prove the world was using the wrong layout. His name was August Dvorak, and he was not an engineer. He was an educational psychologist, someone who studied how human beings learn. That made him look at the keyboard differently than any engineer had. Engineers had designed typewriters around the machine. Dvorak wanted to design a keyboard around the human hand, so he started measuring. Dvorak tracked how far fingers traveled across a keyboard during a full day of typing. He charted which letters appeared most often in English text and which fingers were strongest. He studied hand alternation, how switching between left and right hands mid-word reduced fatigue and increased speed. His team tested 250 different keyboard arrangements before settling on one. In 1936, he patented it. The Dvorak simplified keyboard put the 8 most common letters in English directly on the home row, the row where your fingers sit when you're not moving them at all. On QWERTY, the home row types only around 30% of common English text. On Dvorak, the home row handles over 70%. Your fingers move less, work less, and rest more. Dvorak said it was faster to learn, faster to use, and easier on the hands. And then the US Navy decided to find out if he was right. During World War II, the Navy ran a controlled study. Take trained QWERTY typists, retrain them on Dvorak, and measure the difference. The result, retraining paid for itself within 10 days. 10 days of higher productivity covered the entire cost of switching. That should have been the end of the story. But there was a problem with the evidence. Much of the early research supporting Dvorak had been funded by Dvorak himself. He was the researcher, the inventor, and the funder, all at once. Later, independent studies produced murkier findings. Some showed modest speed gains. Others showed no meaningful difference at all. QWERTY defenders seized on that uncertainty and never let go. If the data wasn't clean, why risk the disruption? That argument was enough. By most measures, Dvorak had built a keyboard that was at least as good as QWERTY, and probably better. But probably better wasn't enough. By the time Dvorak published his findings, millions of people already typed on QWERTY. Entire school systems had built curricula around it. Every office, every typing pool, every secretary in America had trained their hands on the same 26 keys, in the same fixed order. Dvorak didn't just need a better keyboard. He needed to convince an entire country to unlearn what their fingers already knew. He never managed it, and what stopped him wasn't politics or money or a more powerful competitor. It was the simple, brutal fact that switching costs more than staying put, even when staying put is the worst choice. That force has a name, and it turns out it doesn't just explain the keyboard. It explains why most bad standards never die. Economists call it path dependency. It means a decision made in the past controls what's possible in the future, even when the original reason for that decision no longer exists. The past doesn't just influence the future, it traps it. QWERTY might be the clearest example of path dependency in the modern world. When computers replaced typewriters, the mechanical problem that created QWERTY disappeared completely. No type bars, no jams. The entire reason the layout existed had been erased. And yet, nobody changed the keyboard. Because by then, the cost of switching wasn't mechanical. It was human. Every typist in the world would need retraining. Every keyboard manufacturer would need to retool its production lines. Every school curriculum, every typing manual, every training program, rewritten from scratch. All of that upheaval for a modest improvement in typing speed that most people would never even notice. The numbers back that up. A study in 1975 found that a skilled typist on QWERTY could reach over 90% of the theoretical maximum typing speed. 90%. QWERTY isn't great, but it's good enough. And good enough, once adopted by billions of people, becomes permanent. The keyboard isn't the only place this happened. The United States still measures distance in miles and weight in pounds, a system the rest of the world abandoned decades ago. American railroad tracks were built to a specific width in the 19th century, and every train, every platform, and every tunnel on the continent was built around that same width. Not because it was optimal, but because it was already there. Thomas Edison built the first electrical grid in America using direct current. Nikola Tesla proved that alternating current was more efficient for transmitting power across long distances. The science was not in dispute. Edison had already wired too many cities. Replacing the infrastructure would have cost more than living with the inferior system. The pattern is always the same. A standard gets adopted early, spreads fast, and builds so much infrastructure around itself that replacing it becomes harder than tolerating its flaws. Not because it was the best option, because it was the first option that reached critical mass. The typewriter jam that started all of this was fixed over a century ago. But you are still typing on a layout designed around it. Not because it's optimal, not because anyone sat down, compared the options, and chose it deliberately, but because in 1893, a group of typewriter companies agreed on a standard and the world never looked back. Your keyboard is a fossil, preserved not because it works well, but because too many things were built around it to let it die. And you'll probably use it for the rest of your life. Dvorak wasn't the last one to try. In the decades after his defeat, dozens of alternative keyboards were built, tested, and launched. Some were designed by engineers. Some were designed by AI. One was built specifically for your thumbs. None of them won. In 2006, a software developer named Shai Coleman released Colomac. Coleman had studied the same problem Dvorak studied: finger travel distance, hand strain, letter placement, and he came up with a different answer. Colomac kept 17 of the 26 QWERTY keys exactly where they were. The idea was simple: keep enough of QWERTY familiar so that switching didn't feel like starting from zero. At the same time, it moved the most common English letters onto the home row, the thing Dvorak had done, while cutting the total distance your fingers travel per word. It was a smarter entry point than Dvorak, easier to adopt, harder to dismiss. Colomac built a small, dedicated following, mostly programmers and writers who spend their entire working lives at a keyboard and care deeply about every keystroke. It is now the third most popular keyboard layout in the world. Third place, out of 3. QWERTY and Dvorak still hold essentially all of the market, and Colomac's share is too small to measure in any survey of general users. Then came a completely different approach. By the early 2010s, billions of people were typing on something that had never existed in Scholz's time: a touchscreen. No type bars, no physical keys, no mechanical constraints of any kind. For the first time since 1873, the slate was completely blank. Researchers at the Max Planck Institute and the University of St. Andrews took the opportunity. They built KLQ, a split keyboard layout designed specifically for two-thumb typing on smartphones and tablets. They didn't guess at the best arrangement. They used computational optimization, running millions of simulations to find the layout that minimized thumb movement and maximized speed. In lab tests, KLQ was faster, not slightly faster. Trained users typed 34% more words per minute than on a standard touchscreen QWERTY layout. The evidence was objective, peer-reviewed, and published. Pick up your phone right now. You are not using KLQ. Nobody is. KLQ ran into the exact same wall Dvorak hit 80 years earlier. People already knew how to type, and they didn't want to start over. It didn't matter that KLQ was provably faster. 34% faster still wasn't enough to make billions of people unlearn their muscle memory. Think about what that means. Today, there are more than 15 billion devices in active use around the world that carry a QWERTY keyboard. Phones, laptops, tablets, ATMs, smart TVs, medical equipment. Every single one that ships with QWERTY pre-installed makes the next alternative less likely to break through. Each new device is another brick in a wall that no keyboard layout, no matter how well designed, has ever been able to climb. But here is the detail that reframes everything. Christopher Latham Scholz, the man who built QWERTY, was not satisfied with it. After Remington took his design and turned it into a global standard, Scholz kept working. He spent the rest of his life drawing up alternative keyboard arrangements he believed were more efficient than the one he had already given the world. In 1889, 1 year before he died, Scholz filed a patent for a completely different keyboard layout. The man who created QWERTY spent his final year trying to replace it. He knew, better than anyone, that it could be better. The world didn't care. His patent was never manufactured. Every challenger since Dvorak, Colomac, KLQ, and dozens of others has failed too. Not because QWERTY is good, because replacing it would require retraining every person on Earth who has ever learned to type. That number is now in the billions. So go back to the title of this video. Your keyboard is designed to fail. That's true, but not in the way you probably assumed at the start. It isn't designed to fail at typing. It's designed so that nothing can ever replace it.